adored as the protector and ruler of the eternal city. For the Romans, Jupiter was the king of the gods, the lord of the sky and thunder, father of divinities and men, the personification of ultimate greatness, the presence of a supreme mind, upon which the foundations of Roman mythology were laid. Legend has it that seated on the throne of Mount Olympus, the king was captivated by the beauty of his sister Juno, the most precious of all goddesses, whom he made his wife, writing the first chapter of a story of love, jealousy, and deceit. Juno became the queen of the gods, ruling from the heavens, observing the world resting at the foot of her throne. A deity associated with marriage and, above all, loyalty, a quality her husband never shared. Jupiter had countless extramarital relationships that he tried to hide from his wife. With his power, the king concealed his infidelities behind dense clouds, trusting to blind Juno from the heavens, unable to see what was being done under that veil of darkness. But he was underestimating the supremacy of the goddess. Juno could look through the clouds, penetrate thick fog with her divine eyes, and behold, like no one else on Olympus could, the true nature of Jupiter. Only she had the power to glimpse into the corrupted heart of the king of the gods. With the ambition to increase our understanding of the nature of our siblings in the Empire of the Sun, NASA developed a new space exploration program approved by the US Congress in 2002. Dubbed as New Frontiers, it's a series of missions executed by the agency to inspect the worlds and moons of the solar system with the new technologies of the 21st century. A new era in the research of the children of the Sun and the wonders hidden within it. And among all the objectives in mind, one stood out above all: the king of the solar empire. A mysterious, immense, almost intimidating planet that hides its violence under a precious canvas painted in its clouds. A world that we named, in honor of the Roman god, father of all divinities, as Jupiter. A monster. A gas giant that harbors 70% of the mass of all the planets in the system, composed almost entirely of hydrogen and helium, something that reveals it had to be born in the early days of the Sun's reign. Jupiter is probably the oldest of the worlds, forged at the dawn of the kingdom. In its depths, therefore, lies the history that determined the fate of all the children of the Sun. A story that has always remained hidden beneath its impenetrable clouds. Like the god who concealed his secrets under darkness. Under Jupiter's clouds rest the remnants of an ancient era. If we wanted to understand how it all began, there was only one destination. And from the conception of the New Frontiers program, we were very clear about the journey we had to undertake.
En cierto sentido, el corazón de Júpiter era una cápsula del tiempo. Si queríamos entender cómo empezó todo, teníamos que saber qué se esconde bajo sus nubes, y sumergirnos en las entrañas del rey requería de algo único. Si Júpiter era la puerta a los secretos de nuestro pasado, necesitábamos a alguien que portara la llave.
Excited about the possibility of conducting the definitive exploration of Jupiter, NASA made the mission to that world the second in the New Frontiers program. As early as July 2005, the agency began planning a mission that intended to see what lay beyond the clouds of the god could only be baptized in one way. The Juno probe had just been conceived. With a budget of $1 billion, hundreds of scientists and engineers from 5 different countries focused their lives on designing a probe that would navigate the fiercest environment in the solar system. to patrol the skies of a powerful king to behold its heart. Juno was designed as a massive probe with a diameter of 21 meters that was to be the first explorer of Jupiter in a polar orbit, which meant it would not circle around its equator, but its trajectory would take it from one pole to another, navigating uncharted terrain. The design included 3 solar panels, each 9 meters long, which would harvest the faint energy from a sun 500 million kilometers away, and could be deployed when the time came without affecting the range of vision of the instruments. Engineering feats that would work magic. Juno, like the goddess it was named after, needed special powers to see through Jupiter's veil of clouds. Electronic devices that would allow it to conduct unprecedented studies of its magnetic field, its atmosphere, and its interior, and above all behold its heart, the planet's core. For this purpose, its central part was designed to house the scientific instruments, a particle detector, an ultraviolet camera, a microwave radiometer, and although an unnecessary luxury for the mission itself, a visible light camera. The Juno cam was going to offer us incredible images of Jupiter's wonders. Similarly, the probe had to have strong protection against the radiation it would encounter nearby and the cold of the outer solar system. To shield Juno from these threats, all its components were made with radiation-resistant materials and, in turn, encapsulated in a 200-kilogram titanium chamber. Juno had to become a tank. With the design and construction completed after years of work and having completed all the deployment tests of its panels, Juno underwent a final examination. It was introduced into a vacuum chamber filled with liquid nitrogen that reduces the temperature to minus 180 degrees, simulating the conditions it would encounter out there. Having verified that everything worked, there was only one final step. The spacecraft was transported to the Cape Canaveral Space Launch Complex 41 and loaded onto the Atlas V, one of the most powerful rockets in the world. Thus, as the culmination of years of dreams and hopes, on the morning of August 5, 2011, Juno began the journey to the King. Crossing the Earth's atmosphere in just 10 minutes to never return home. Once in its orbit, the rocket's fairing is released and Juno emerges from its hiding place. Firing its thruster initiates the rotation, and the journey begins. Juno has ahead of it a journey of 1.7 billion kilometers, which includes a gravitational assist with the Earth itself to escape the gravity of the Sun and reach its destination. A perfectly orchestrated gravitational dance in which for 5 years, we can do nothing but wait. But finally, on July 4, 2016, more than a decade after its conception, Juno arrives at its destination. It's time to settle in the King's empire. With a speed of 265,000 kilometers per hour, the probe must immediately slow down. Any failure could mean it would be lost in the vacuum of space or devoured by the god. To enter orbit, Juno executes a 180-degree turn, and a firing of its thruster for exactly 2,102 seconds reduces the speed of the spacecraft by 542 meters per second. Surgical precision allows Juno to insert itself into that never-before-achieved polar orbit. Very close to the giant, just 5,000 kilometers above its high clouds, Juno points its camera towards it, giving us images that show the beauty of the world. Winds of up to 650 kilometers per hour lift cold clouds and turn them into artistic swirls. Mosaics of furious storms dancing over an unexplored heart. The closest we've ever looked at it. Juno has already begun to reveal Jupiter's secrets. The king has finally begun to speak. But at the same time, All its fury is ready to prevent this outsider from inspecting its heart.
Júpiter es uno de los ambientes más peligrosos que una sonda puede navegar. Cuando lo sobrevoló en 1973, la Pioneer 10 obtuvo los primeros indicios de un cinturón de radiación a su alrededor. Hoy sabemos que cerca del mundo, los niveles de radiación son 30 veces superiores a los que se midieron dentro del reactor de Chernóbil durante el accidente nuclear.
With the aim of discovering the origin of this lethal radiation, Juno focuses all its efforts on investigating the most likely culprit. Jupiter's colossal magnetic field creates a magnetosphere that extends over 600 million kilometers, reaching as far as Saturn, as if the mythological god were casting rays upon it. Such is the size of this magnetic sphere that, if we could see it with our own eyes, it would occupy a portion of the sky similar to the moon. But this astronomical wonder hides a dangerous threat for Juno. High-energy particles from the sun are channeled into lethal radiation belts, guided by a huge magnetic field that traps them to make them its servants. Cosmic bullets that create an invisible shield around it, capable of destroying anyone who dares to enter its domain. Radiation levels are 1,000 times higher than the lethal dose for humans. Not even Juno, an artificial entity with a titanium shell designed to block 99% of Jupiter's radiation, can survive in its vicinity. Therefore, to prevent radiation from destroying it, a unique orbit around Jupiter had to be planned. A series of highly elliptical trajectories that allow the spacecraft to patrol Jupiter's poles passing below the radiation belts, but ensuring that in each 53-day orbit, it does not remain in the high-risk zone for more than 2 hours. Inspecting the origin of the magnetic field, Juno's attention is focused on something closely related to it, and which had been an enigma for decades: Jupiter's auroras. Although in the ultraviolet spectrum, making them invisible to our eyes, the giant has the largest auroras in the entire solar system, which does not fit with our knowledge of these phenomena. On Earth, auroras emerge when cosmic rays from the sun, guided by the magnetic field, head towards the world's poles. Charged particles collide with the gaseous atoms of nitrogen and oxygen in the thermosphere, causing them to gain an electron which, in a fraction of a second, is released in a reaction that releases light. Jupiter, however, is too far from the sun for auroras to form in this way, much less with the intensity with which they do. With an ultraviolet light show larger than our own world, the existence of Jupiter's polar lights seemed inexplicable. Even so, when Juno inspected them, it discovered there were kind of hotspots, regions where exceptionally high concentrations of particles were impacting Jupiter. And reconstructing their trajectory, the path did not lead to the sun, but to a world of rock and fire. A son of Jupiter that hides hell. The closest satellite to the world, Io's moon, is a tiny place where more than 400 active volcanoes dot its surface. Tormented by the gravity of its father, Io's bowels roar, sending streams of fire, lava columns, and ash hundreds of kilometers high. The lava from its volcanoes can rise like skyscrapers into the vacuum of space. But all that material does not vanish into nothingness. Particles ejected from the depths of Io are trapped by the king's magnetic field. The lava streams become jets of charged particles, accelerated along Jupiter's magnetic lines until they impact specific points in its atmosphere. At that moment, atomic excitation reactions ignite, resulting in the birth of auroras. Juno had shown that the king's lights came from the volcanoes raining over one of its suns.
Hasta entonces nuestra visión de Júpiter había estado muy limitada. Todas las misiones previas de exploración habían navegado el mundo en su ecuador. Juno sería la primera que lo haría en una órbita polar, así que llegado el momento, íbamos a entrar en un terreno sin cartografiar.
In August 2016, Juno's first close encounter led us to explore a place we had never seen before. What was hidden in the polar regions was an absolute mystery. And with that inaugural flyby, we saw that its pole was very different from the Jupiter we knew. Juno's camera reveals a strange expanse of electric blue, a polar region where the typical belts of equatorial latitudes disappear, and is dominated by a set of never-before-seen hurricanes. A group of vortices together but not mixed, spinning around the pole at over 300 kilometers per hour. At the North Pole, a colossal cyclone 4,000 kilometers in diameter is surrounded by 8 smaller ones, like a geometric pattern of hurricanes. The blue color may be due to chemical changes in the clouds caused by the lack of solar radiation, but that formation of cyclones becomes a great mystery. On Earth, with a climate dominated by the sun, cyclones form in equatorial zones, where the heat from the parent star has the most intensity, and these weather phenomena are generated. But in polar regions with much less incidence, climatic activity is not enough to form them. In Jupiter, we were seeing exactly the opposite. Instead of being at the equator, hurricanes dominated the world's poles. Being 5 times farther away from the sun than we are, Jupiter's polar regions were the ones condensing these phenomena. Something had to be fueling that strange climate, and our star by itself could not be the culprit. To find the origin, in its orbit, Juno scans the thermal emissions of the world and reveals scorching heat beneath Jupiter's high clouds. The giant has so much mass, so much material accumulated in its bowels, that its fierce gravity makes its interior tremendously dense and hot, with a core probably at temperatures much higher than those on the surface of the sun. This hell buried beneath thousands of kilometers of gas radiates through the atmosphere, through the outer layers and their convection currents, heating its surface from within. Awakening winds that extend to a depth of 3,000 kilometers. Atmospheric rivers embedded far below the surface that we see. As that heat filters through, Jupiter's rapid rotation, completing one rotation on itself in just 9 hours and 55 minutes, generates in the atmosphere those fierce cyclones they had observed at its poles. Because it's not the sun that feeds them, it is Jupiter itself, with its fiery heart, that nurtures its fury. During the flybys, Juno detected strange signals coming from the planet's interior, bursts of radio waves appearing on the detectors at a frequency of up to 4 per second, a telltale sign of the existence of lightning, thousands of times brighter than those on Earth. Jupiter's atmosphere is alive. Clouds move as if following a current, accumulating static electricity that triggers a lightning show in its hidden depths. The thunderstorms are orders of magnitude larger than those of our world, and as Juno had shown, are accompanied by something beyond light. In the upper regions, ammonia, responsible for the orange color of the clouds, was turning into an icy sphere. Hailstones were forming, falling towards the depths due to gravity. But on Jupiter there is no solid surface, only an eternal abyss. Therefore, when hail falls, there comes a point where the currents lift it again, to accumulate more and more ice, in a process that only ends when its mass is sufficient to defy the winds. And they fall to the place where all roads end. But everything paled in comparison to the most famous storm in the solar system. the largest anticyclonic vortex on the planet, a huge whirlwind that could have existed for over 3 centuries, with winds at its periphery approaching 700 kilometers per h and large enough to engulf the entire Earth. In July 2017, Juno flew over its 15,000 kilometers in diameter and photographed the Great Red Spot, showing how 2 convection currents sustain it at a fixed latitude, trapped in its position. The probe's microwave radiometer shows, for the first time, where the roots of the storm lie. The Great Red Spot extends to 320 kilometers below the surface, 20 times the height of the largest cyclones in our world. A power that has an impact on the entirety of the world that Juno is capable of measuring. The thunderous sounds emerging from the interior of the storm create sound waves that behave like pressure waves, compressing molecules in the atmosphere. The sound becomes thermal energy. So in a way, the Great Red Spot has heated Jupiter's atmosphere for centuries. However, Juno's data reveals that this may be about to change. Detailed images show that the storm has lost a third of its width, suggesting that it is only a matter of time before the most famous storm in the Empire of the Sun fades away, leaving only a memory of its majesty. Juno had deciphered the nature of Jupiter's clouds and the magnetic shield around it, but from its conception, it was clear that its mission went far beyond the giant. It had to follow the path of water to understand the moment when on our world, the seed of life germinated.
La Tierra se formó dentro de lo que se conoce como línea de nieve, una distancia en la que el Sol tenía la suficiente fuerza como para evaporar cualquier agua que estuviera presente en su superficie. Teóricamente tendríamos que ser una roca seca en el espacio, y en esa ambición de entender cómo nos convertimos en este oasis de agua contra todo pronóstico, todos los caminos conducían hasta Júpiter.
In December 1995, NASA's Galileo probe ejected a probe that we sent on a suicidal mission into the depths of Jupiter to find evidence of water in its atmosphere. Immersing itself in its clouds, it was able to inspect the composition of a world that we expected to be relatively abundant in the most precious liquid in the universe. But surprisingly, it found nothing. The strange results from Galileo sparked speculation for over 2 decades, until finally Juno arrived to offer a second diagnosis. It searched for traces of water without forcing the probe to venture into a place where death awaits. Knowing that water molecules absorb wavelengths corresponding to microwaves, Juno measures the portion of heat from the world's depths that is absorbed by hypothetical water in the atmosphere. And since it doesn't do this in just one place, but scans an entire plane with each flyby, we can create a map of the giant. Reconstructed in a 3-dimensional sphere, the results show that Jupiter has large amounts of water, and that the apparent lack of it in Galileo's mission was because the probe just happened to dive into a small dry region. They had solved the mystery of Jupiter's lost water. In fact, in one of the orbits they were able to see it visibly. Juno's camera photographed white clouds, very similar to those that inhabit Earth's skies, casting shadows on the lower clouds. They had solved the mystery of the lost water, and above all, found signs of a connection between Jupiter and our home. The concentrations of water found in its atmosphere provided strong evidence that Jupiter did not form in its present location. There was a time, in an ancient era over 4.000 million years ago, when it was twice as close to the Sun, at the edge of the snow line of the primitive solar system. However, the gravitational disturbances from a powerful sibling led it to move away from the mother star. The gravitational pull of a young Saturn pushed Jupiter into the far reaches of the Empire. The king of the planets had begun a migration that would decide the fate of all that we are. In its journey through space, Jupiter unleashed chaos. a gravitational storm in which millions of asteroids, icy relics formed in a region cold enough for water to exist as ice, were disturbed and banished from their orbit. Treasures that guarded the cosmos's gift plunged into the realm of the Sun. With its immense gravity, Jupiter caused countless fragments of rock and ice to rain down for over 300 million years, resulting in an era dubbed the Late Heavy Bombardment. And a young, desolate Earth, victim of this fierce attack, received the liquid that allowed consciousness to emerge in the universe. Jupiter had gifted us the water in which life found a path to flourish. Juno, navigating the vicinity of a gas giant, provided answers to the origin of water in our world, showing that we, everything that has life, are connected to it. But Jupiter still had many secrets to decipher. It was time to embark on one last journey to its heart.
Bajo la atmósfera superior, el hogar de las tormentas y nubes que conforman su mosaico, todo lo que encontramos es puro hidrógeno. Juno tenía que descubrir cómo el más abundante y simple elemento del universo podía generar el tan poderoso campo magnético de Júpiter.
As the axis of a research project on nuclear fusion, the scientists at the National Ignition Facility in California are working to achieve the necessary conditions for nuclear fusion reactions, mimicking the functioning of the sun to generate energy much more intensely than with fission. Using its facilities, NASA scientists had a way to simulate what happens to hydrogen when it is under the extreme conditions in the depths of Jupiter, recreating the scorching pressures and temperatures of the King. The machinery of the NIF allows them to fill a sample of liquid hydrogen on which they will shine 192 of the world's most powerful lasers. The ignition of the electronic components culminates in a concentrated wave with a temperature of 3.3 million degrees. Each laser pulse, lasting just 20 nanoseconds, has a power of 500 billion watts, with all the power focused on the target. The hydrogen is exposed to pressures found 16,000 kilometers below Jupiter's surface. For 1/billionth of a second, they have created the conditions found in the world. And the readings on the sample reveal something totally unexpected. The hydrogen, initially transparent, turns into a substance that reflects light. Under these extreme conditions, a strange state of matter emerges, and hydrogen behaves like a metal. And it is very likely that this is the main actor in the depths of Jupiter. In its depths, hydrogen atoms are pressed with such intensity, the pressure makes them so close together that they inevitably begin to share electrons among themselves, the pure definition of a metallic bond. The atoms cluster to form a very compact structure that above all is capable of conducting electricity. This peculiar form of metallic hydrogen was solving the mystery of Jupiter's colossal magnetic field, whose origin was completely unknown. Juno's results showed that this ball of metallic hydrogen could represent up to 50% of the world's mass. Half of the most colossal planet we believed was a gas giant could be an immense sphere of liquid metal. A metal that, forced by the rotation of the planet, spins relentlessly. A movement that creates electric currents and the dynamo that generates the most immense magnetosphere in the solar system. The discovery of this ocean of liquid metal shed light on an anomaly that Juno had found a few months earlier. Maps of the magnetic field showed that in addition to the north and south poles, there was a magnetic disturbance at the equator, a region they called the Great Blue Spot, and that was behaving like a third pole, something we had never seen before. But now, finally, we were close to finding its origin. Juno's images showed that the fastest winds condensed at the equator. hypervelocity currents whose influence could reach depths of 3,000 kilometers, the place where that ocean of metallic hydrogen rests. The winds traversing its surface can create anomalous flows in the liquid, currents in the ocean of metal that disturb the dynamo of the entire planet, causing that strange third magnetic pole to emerge at the equator where the anomaly concentrates. Juno had begun to clear the darkness, to observe what the god hides. But there was still one last journey. A journey to a place where all paths end.
El corazón de Júpiter es un lugar donde el tiempo se congeló, una ventana a una edad antigua que determinó el destino de todos los hijos del Sol. La verdad siempre había estado escondida bajo esas nubes, miles de millones de años, esperando a que nosotros miráramos en su interior.
The ultimate mission of Juno was to unmask the nature of Jupiter's heart. And to do that, to remove the veil of darkness that guards its secrets, it only needed to use one thing: gravity. Juno traces an orbit that takes it so close to the giant that small gravitational disturbances in its depths can affect its movement. Depending on what lies within, hidden behind the clouds and the ocean of hydrogen, Juno will describe a unique dance. Denser regions will pull the probe inward. Less dense regions will release it outward. The trajectory will be curved as a result of mass concentrations beneath its surface. Essentially, they are going to use that gravitational dance to reconstruct its heart. The minute variations in Juno's speed and position cannot be observed with the naked eye, but they can be measured through the Doppler effect in its radio signals. By listening to the change in frequency depending on whether it is approaching or receding, they can deduce its velocity, and with that, describe the gravitational perturbations to which it is exposed. Aware of the precision they would need, the engineers at the Goldstone Observatory in California joined Juno's mission. A 34-meter radio antenna with the sensitivity required for the operation listens to the signals from the probe where the messages of gravity are encoded. Minute by minute, listening to the symphony, Juno is allowing them to reconstruct the center of the world. The goddess Juno finally is contemplating what her husband has hidden for so long under that veil. The gravitational dance suggests that a dense material rests in the heart, too massive to be just hydrogen and helium. Everything seems to indicate that what lies within is rock at extremely high pressures and temperatures. Subsequent reconstructions confirm this colossal sphere of rocky material, large enough to be a planet itself, 10 times the mass of Earth. But at the same time, they hint at something more in that heart. Gravity betrays the existence of an extra layer around that sphere, consisting of dissolved and mixed hydrogen and rock. A type of planetary core that had never been observed. A strange and diffuse gaseous and solid alloy whose existence did not fit with our knowledge of the birth and evolution of the worlds of the universe.
Desenmascarando su corazón, un nuevo enigma se presentaba ante nosotros. Nunca habíamos visto un núcleo como el de Júpiter, y solo una teoría parecía darnos la respuesta. Una teoría que nos transportaba al momento en el que todo comenzó, para presenciar la forja de los hijos del Sol.
At the dawn of our home in the universe, when light sprouted in the depths of a dark drifting cloud in an ocean of emptiness, the history of the sun's empire began to be written. A symphony of light, gravity, and dust. Trapped by the power of the primitive mother star, tiny particles began to orbit around the sun, and the forge of the father of all his children began. Attracted by its minuscule gravity and static electricity, The particles slowly unite to form pebbles. Pebbles that will turn into rocks and rocks that will eventually give rise to planetesimals. An object with a diameter greater than a kilometer and whose internal force is already dominated by its own gravity. Bodies that, entering into struggle, colliding and merging with each other, have created the seed of the king, an entity 20 times the size of our world. The heart of Jupiter has been forged. A ravenous monster with unmatched gravitational power, devouring everything that enters its domain. The giant grows to the point of crossing the critical mass that allows it to absorb the gas around it. A primitive Jupiter of rock absorbs the hydrogen and helium adrift in that young solar system. A new era for the king has begun. The god is dressing in his most elegant attire to forever hide the heart with which his days began, but at the mercy of an unavoidable gravity. In a realm where worlds were still at war to claim their thrones, someone wanted to fracture that treasure. A fierce son of the sun, a planet 10 times more massive than Earth, ventured too close to the god of the sky and thunder. The battle between giants is inevitable. Destiny has been sealed. An unprecedented collision in the history of the solar system leads that outsider to penetrate Jupiter's colossal atmosphere. A world is plunging into its darkness to destroy its heart. Hidden under the veil, the impact disintegrates the entrails of the king. Jupiter has survived, but its heart has changed forever. It has been left in ruins, in a state between life and death, in a mixture of gas and rock, unable to repair. The collision with that world not only spawned the strange core that Juno had unmasked, it also left a legacy in the form of energy. Heat that is still trapped in its entrails today, contained like a treasure, feeding Jupiter's infamous climate. The ashes of that tale of destruction are still there inside, a story imprinted in the scars of its heart. Juno had given us everything she had promised, but her mission is not over yet. She will continue to navigate its skies until the fury of the king ends her life.
La misión de Juno iba a terminar en 2018, pero ha sido extendida varias veces. Con los 56 sobrevuelos que lleva, ha descifrado los grandes enigmas de Júpiter y más recientemente de sus lunas. Se prevé que seguirá explorando el sistema hasta septiembre de 2025, momento en el que probablemente estará ya muy cerca del final de su vida.
Juno's lifespan was always very limited. We thought she wouldn't last more than 6 years enduring the extreme conditions near the world. And although she has far exceeded everything we had planned for her, there will come a time when the radiation accumulated in her instruments will reach a point of no return. A poison that will mark the end of the road in a short time. When that moment comes, and in compliance with planetary protection policies, knowing that some of Jupiter's icy moons like Europa, Ganymede, and Callisto could be reservoirs of extraterrestrial microbial life, we will have to force Juno to sacrifice herself. To prevent it from crashing and contaminating those worlds, engineers will send it on an irreversible path. Juno, in a final maneuver, will plunge into the depths of the king she has contemplated from the skies for years. It will traverse the clouds on a definitive journey to the place where all roads end. After so long, husband and wife will be united again. The culmination of a destiny that had always connected them. The king had finally told us his story. Juno could finally rest, fade into the darkness to become part of a god's heart.